Hi everyone, thanks for joining the CIGRE UK technical webinar. I'm Jianing Li, Principal Power System Engineer from WSP UK. I'm also the chair of the CIGRE UK NGN. And for today's webinar, we'll mainly have two speakers for the topic of development of grid-forming converter for secure and reliable operation of future electric system. We also have Professor Xiao-Ping to introduce the joint working group B4/C493. The event is jointly organized by CIGRE UK, CIGRE B4 Study Committee and its joint working group, CIGRE UK NGN and CIGRE France NGN. And the event is kindly sponsored by Burns and McDonnell. For today's agenda, I will have a brief introduction, and we're going to have a background introduction to the joint working group and its ongoing activity from Professor Xiao-Ping. And we're going to have introduction to CIGRE UK NGN and France NGN. We're going to have the two speakers to share the insight to this joint working group, their ongoing related technical development in grid forming converter and or engagement experience in this joint working group as NGN members. And we will have the Q&A session at the end. Now let's welcome the first speaker, Professor Xiao-Ping. So Professor Xiao-Ping Zhang is a professor, a chair of electric power system at the University of Birmingham. He is the director of Smart Grid Birmingham Energy Institute, co-director of Birmingham Energy Storage Centre, sponsored by the UK, head of the Electric Power System Control System Group. So welcome.
Thank you, Jianing, for your introduction. So it's my great pleasure to take today's opportunity, give you an update for joint working group B4 C4.93. This is on the development of grid-forming converters for secure, reliable operation of future electricity system. My presentation structure covers brief introduction of the background, scope of the working group, structure of the working group. Then we're going to give you an update of this working group recent activities. Finally, I'm going to talk about the role of NGN members in this joint working group. Just give you a little bit of background of this joint working group. Of course, fundamental challenges related to climate change. So therefore, we have to move towards renewable energy supply system. However, this brings two key trends for future electricity system in support to global net zero energy transition. Number one, we're going to have a power electronic dominated power grid system to support the high penetration of renewable energy into generation, transmission, and energy services. The second trend is the traditional large-scale fossil thermal power plants continuously replaced by the renewable energy sources. The consequence is very significant. We got big trouble to deal with the system frequency and stability. Fortunately, there is an emerging technology, so-called grid-forming converter-based technology. Briefly, grid-forming converter can be represented as an independent voltage source to provide voltage and frequency reference. So in some sense, we can use grid-forming converter to mimic the functionality of conventional synchronous generators. So therefore, the key idea is we develop such functionality so that we can somehow mimic the functionality so that we can still maintain, even improve system stability of the future electricity system. Consider such a potential benefits from the grid-forming technology. Grid efforts, therefore, are urgently needed for the two purposes below. Number one, to explore potential function services of the grid forming converters for secure, reliable operation of the future electricity system, so as to support net zero energy transition. Number two, to achieve dominant design for a wide range of power electronic-based technologies, facilitating potential opportunity in certain region markets and services. The scope of the working group can be summarized below. To review definition of different grid forming capabilities, to survey existing grid forming functionalities, so therefore investigate potential new ones resulting from different power electronic based technologies to maintain and further improving system operability for future electricity system, to investigate effective analysis methodologies, tools, models to support performance validation of the grid forming converters based on different technologies, to define high-level technical requirements for network services, to develop models, benchmark simulation testing system, as well as relevant testing specification for compliance testing of grid forming converters, to provide high-level evaluation of feasibility to achieve identified requirements between grid forming technologies as defined in this term of reference, to share global good practice of development and deployment of grid forming converters. This last, at least, in my view, is very important to share the best practice so that we can develop the technology better and quicker. Now it's time for me to talk about a bit structure of the joint working group B4 C4.93. At first, I want to introduce the convenor of the working group. This is Dr. Dechao Kong from National Grid. He is a power system engineer in National Grid Electricity System Operator. He is also a regular member, in fact, the chair of CIGRE UK B4 Study Committee. Now I want to show you the structure of membership and their backgrounds. So left-hand side give you a sort of flavor, distribution of the members, the roles. We have expert, NGN members, and observers, so on. Right-hand side diagram show you the distribution of members from different industry sectors. For instance, from TSO, developer, manufacturer, R&D companies, consultancy companies, and so on. I want to show you very briefly some recent activities of the joint working group. This is photo taken from the kickoff meeting on 29th August during the CIGRE 2020 Paris session. You can, from this photo, you can say we have pretty good attendance. By the way, actually, the meeting was a hybrid event. We also got quite some members join the meeting from the online system. Now later on, we have following activities. For instance, we have the virtual kickoff meeting on 7th September. We have two big technical group meetings for discussion agreement of the 6 main topics for joint working group technical brochure chapters. This happened October 2020. According to the group voting result and coordination, resource assignment, 6 subgroup have been allocated and we have individual technical brochure chapters associated with these subgroups. We have appointed subgroup co-leads, technical secretary, and members in November last year. Also, we have a follow-up subgroup preparation meetings in December last year, also January this year. I think some of the meetings still going on in this month. Detailed work will be carried out in most of these subgroups. These activities will pretty start from the end of January this month. The 6 subgroups covering following topics. The first subgroup is about definition of grid forming converters as connected into power system. The second subwork group is about the provision of system services from grid forming converters for secure, reliable operation of future power system. The third subgroup is about tools for planning, design, operational grid forming converter applications. The fourth subgroup is our grid forming benchmark test system and models for compliance purpose. Subgroup 5 is about the compliance testing for grid forming converter applications. Subgroup 6 about good practices of grid forming converter developments and deployments around the world. So finally, I want to show you the important role of the NGN members in this working group. So in our philosophy, NGN members are encouraged to observe and contribute to this joint working group or relevant activities. For instance, some NGN members volunteer in support to this joint working group, as shown with detailed and important role in this table below. Knowledge contribution to this joint working group and dissemination for CIGRE community at a wide based on their activities and the learning from this joint working group. I'm hoping through this working group and other working group, NGN members going to play increasing roles in the power community. We really, particularly through this working, we already benefited from the participation of the NGN members. I'm hoping through your contributions, we can produce very rich outputs. And thank you very much for your contribution. And I really appreciate your time and contribution. And I think probably discussion would be at the end of the session. Am I right?
Yes, Q&A will be at the end of the session. Thank you so much.
Thank you, Jianing. That's my presentation. Hope you enjoy the events. And if you have any questions, want to have further discussion with us, can either contact the convenor, Dr. Dechao Kong from National Grid, or myself, Xiao-Ping Zhang, Professor of Electric Power System from Birmingham, or Jiajie, the NGN member, or other NGN members involved in this working group. Thank you very much.
Thank you for the Xiao-Ping. Thanks for your very exciting presentation and introduction to the joint working group. And as Professor Zhang mentioned, if you're interested in the working group, please get in touch with the convener, Dr. Dechao or Professor Xiao-Ping. Thank you so much. Next, I would like to welcome Siva to introduce CIGRE UK NGN. So Siva is the event team lead of CIGRE UK NGN. Siva, please.
Thank you, Jingo. Let me share my screen. Can you see my screen? Okay.
Yes, I can see your screen.
Okay, thank you. So thank you, Jingong, for the introduction. And I welcome you all to the joint collaboration between B4. This is like the third collaboration we are doing with B4. And we also have our France NGN counterpart who have helped us through this. So myself, I'm Kaviya. I'm working as a software engineer as part in the software called IPSA as per TNAI. And this is a short introduction about myself. I'm now working as a software engineer in TNAI. I graduated from TU Delft, and my area of expertise are as below. So I would like to start with what is CIGRE UK NGN's benefit is. So this is the perfect place to be if you are a starter in young professional who wants to know more or have a network or have both the combination of academia and industrial experience. And it's a great networking opportunity, and we have a lot of events planned like the technical webinars. Even through the COVID time, we have been successful, and we also had some site visits, and we also have some upcoming site visit, and we always plan events with other counterparts around the world, and also with all the study committee and joint working group. So it's like the gateway to CIGRE, and the gateway to me, I feel it's the gateway to the power industry networking group. So I would like to introduce the team. So as you already know, Jingang Lee is the chair of CIGRE UK NGN's 2023. And we have Georgia Lu, who is also presenting as a speaker for the joint working group. He's our vice president. And we have Nanchan, who is also the secretary. We have Jingo Han, who is the membership lead. If you need any help with CIGRE NGN membership, please do contact her. Myself, I'm events lead, and I'm also the international representative for UK NGN. And we have Jesus, who is also I'm a communication lead and who would be responsible for all the social media activity. And we have Max. Max is the technical lead who will be responsible for organizing all the events like mentee mentorship program and also NGN showcase competition. And we also have been supported by our coordinators. So we have Kirti and Louis who's joined the events team, and we have Margie and Victor who's help Max, and we have Maria who also is helping Jingua with the membership team, and we have Jingi who is also an international representative and marketing coordinator for the UK engine. We have you is the ex-chair of CIGRE UK NGN, and he's also a supporter for us. So as I already said, the benefits is that for the first 3 years of after graduation, you have a free membership, and if your company has a collective membership, you can always have access to all the CIGRE papers and also join working groups and join all the NGN steering committee, and you can also be part of CIGRE conferences. So this can be your gateway to chartership as well. So we had a few various events, previous events like as follows. So some of them is like Alstom Grid VCS demonstrator tour and talks. I think this is all from pre-COVID times, and we have member technical. During the COVID time, we were successful in doing online webinars as follows. So the past webinar was on July 2022, where we had a webinar with the Australian counterpart, and we had on changing electricity market, and then we had a very creative event on innovation and creativity event, and we had a event with Romania like the green technologies and energy storage, and we also had an event with France on offshore wind development, and we had one more webinar with Australia on cutting and edge technology. And we had two prior collaboration with B4 on grid forming technologies and opportunity and challenges for HVDC. And we had a diversity inclusion event with Italy, and we had some events with China and Netherlands. And we were even during COVID, as I said, we have been continuing the webinar successfully, and we hope to have a many in-person event this year. So one of the in-person event I would like to highlight is the CIGRE UK Paris event, where we got the opportunity to be present, me and my colleagues, and some of us had presented paper. We also sent three young member showcase who also were part of the CIGRE Paris event, and we also represented CIGRE UK NGN. So if you have any queries, or if you want to know more, or if you want to join us, please do follow us in the upcoming in the social media pages, or reach out to me in case of any queries. Thank you.
Thank you so much, Siva. Can I invite Nicolas, please, to introduce France NGN?
Let me know if you can see the screen.
Yeah, you can see the screen. Thank you.
All right, perfect. So basically, I'm on the same view as the presentation of Siva. So I'm gonna be fast, because the French NGN is just the French iteration of next generation network, and we're organized a bit the same way as the UK NGN. So our objective is to promote our professions and our networks to students. This is the first goal, actually, of the French NGN, is to open to students and, of course, young professionals and young members. But we have a lot of work to do with students. So we create, of course, this network of young members within CIGRE, and we are the gateway to CIGRE, as Siva introduced it. We organized a lot of events that are not only webinars dedicated to everybody, but also events specially for young members. I'll come back to that. And we collaborate, like in this webinar, with international groups to co-host events. So our members, we have a central office composed of very diverse companies, such as GE, RTE in France, the SuperGrid Institute, from which we have a speaker today. Capsim, Gmelec, so very different companies of different size and very different points of view in the central office. A lot of young members and a lot of students, and of course you can join us in the standard networks, professional networks. We had a lot of online events during the COVID period, but also after. Like students webinars, in which we introduced our profession to students and answer their questions. The point being to have them understand the professional world with young professionals. We had technical conferences, and also we had a very successful run of events called Objective Top Chef. The point is to get a top manager from any company in the business, and to have a very open discussion, to have their feedback, to get some advice on career choices. So far, we had 4 events. One of them was in collaboration with the Women in Energy Network, and these were very, very successful events. So we are trying to promote them as well to other NGN networks. We also had in-person events, one in SuperGrid in 22, which was a seminar for young members in France, so they could join one day for an NGN event. We had collaborations with Women in Energy in Paris, and finally, as we are in France, we are close to Paris, and we can help organizing the Paris session. So we organized this year the technical visit with RTE. And the technical booth. So people who join the French NGN can be involved in these activities as well. So thank you for being in this webinar. That's very nice to have a co-event with the NGN UK now, and now is the beginning of the, let's say, technical topic. So I leave the floor to our speakers. Thank you.
Thank you so much, Nicolas. Next, let's welcome the first speaker, Jiajie Luo. Jiajie is a software and control engineer. His main responsibility is research and development. He's currently the vice chair of CIGRE UK NGN and also secretary of CIGRE UK. Prior to this, he graduated with his PhD in his research topic on modeling and control of multi-level converter for offshore wind farm applications. The floor is yours.
Hello, everyone. Before I start, can I confirm again you can hear me and hopefully see my slides all right?
Yes, we can hear you. We can see the slides. Thank you.
Fantastic. Thanks, Jianing, for the introduction. And my name's Jiajie, and today I would like to share some personal experience from the angle of an NGN member for this joint working group on grid forming. Contents include a very brief self-introduction, then benefits of participating in the CIGRE working group, and how to get involved if you're interested, and my responsibility, some challenges, and also touch a point on a side test experience on grid forming from my company, Siemens Gamesa. About me, I'm currently a software and control engineer at Siemens Gamesa. Been there around 4 years now, looking after the converter control software. Before that, I was a PhD student at University of Birmingham. Besides my main work, I also volunteer. One is in CIGRE UK NGN as the secretary and treasurer last year and vice chair this year. Also, another one would be the technical committee as the secretary since October 2022. And as I see it, there are quite a few benefits of participating in CIGRE working group. The first one is that you would be able to address key issues of the most cutting edge technologies. To me, being a part of it, it's already a reward. And the next one, obviously, there's a pool of experts within CIGRE, and you would be able to learn from that, especially your young engineer or new graduates. Also, you could broaden your social network with people from all different backgrounds, for example, from universities, from manufacturers, from consultancies, etc. And sometimes talking to them can create some idea spark, which is great. And the last one would be a skill enhancer. I only list 2 here, but the list can easily go on. Writing skill, as we need to produce technical brochure, electric reports, also communication skill, as we need to make effective communication with people from another background, maybe another country, and to put another one, maybe time management skill, as you need to balance your main work and your voluntary work, etc., etc. And with all those benefits mentioned, the question being how to get involved then. Firstly, if you're not a CIGRE member yet, I would strongly recommend you being one. If you're a student or a young engineer, NGN member might be suitable for you. Otherwise, individual member, or if your company is a collective member, you can also join via your company. Then you could go to the CIGRE website to find what working group opportunities are open now. And don't forget to subscribe the CIGRE mailing list so that you can get the message of new working group requires new members. But if somehow you miss it, they normally included in our monthly newsletters, and the technical committee annual report would be also a useful source which summarize all the working group activities at the end of each year. Regarding my responsibility as an NGN member, I've put down a few. One, to do survey, for example, collect options on meeting or subgroup selections. Here shows an example so that we can collect responses and analyze responses before the meeting and arrange meeting, writing meeting minutes, and also contribute to data management platform like KMS knowledge management system. All right, so far I've been talking all about the good stuff, but each coin has two sides, right? And I would like to also mention some challenges we've met so far. The first one, and also an obvious one, would be the time difference among members across the globe. We have members in Europe, but also in China, Australia, sort of Pacific area, and also members in the US. So no matter what time we put it as the meeting time, there'll always be someone who's sleeping. So at the end, we had to, for big group meetings where we expect every members to join, we had to actually arrange two sections so that people can pick the one which is more suitable for their time zone. Another one, we can make use of the tools, for example, the survey tool I just mentioned earlier, so that we can actually move part of the work before or after the meeting, and related to that, we can shorten the meeting time so that the members can have a better chance to catch the meeting, and recording as well, so that if one or two members have to miss that day, they could watch the recording later. And last one would be occasionally we arrange some physical meetings. Second issue regarding IT is actually voted by our members. For instance, the accessibility to KMS. In that case, we help them creating a new KMS account, and some area Google might be blocked. Then again, we encourage and suggest them to use KMS. And the next one, I would like to introduce to you a side test experience on grid forming from Siemens Gamesa, but noted that due to confidential reason, I cannot include too many details in my presentation today. As far as we know, it was the first UK converted connected wind farm to operating grid forming. Wind farm called Dechao in Scotland, operated by Scottish Power. There are 23 turbines, totally 69 megawatt farm there, operated in grid forming for 6 weeks back in 2019, and they are all direct drive full converter PMSG, what we call D3 in short. Those pictures taken when I visit there once back in 2019, very environmental friendly business. We produce electricity, also produce cashmere. So among those 6 weeks, fortunately, we were able to capture some events, which actually might be unfortunate for other parties. So the first event I would like to share with you is the IFA interconnection trip on 31st May, resulting in an in-feed loss of around 1 gigawatt, rock-off rate of change of frequency peak at minus 0.11 hertz per second, total drop of frequency near 0.5 hertz, which you could see from the plot to the right. First one being frequency dropping, the second one rock-off. And with grid forming control, we expect the wind turbines to produce extra power to support the frequency drop events. So the third one shows the red line as the power reference and the blue line actual power output. So the difference between the two plotted as the fourth plot shows the actual power we produce as because of the grid forming algorithm. So regarding the turbine setting, we set the inertial constant to 4. The bigger this constant, the bigger the power output we're expecting. And we expect around 1.4 megawatt peak, and our actual measurement matches that well, which proves that our algorithm on grid forming work all right. The next event I would like to share is a synthetic event, which is -1 Hertz per second, 3 Hertz drop in total. The wind turbines were told to react as if such an event has happened. And this time, the inertial constant is set larger, much larger at 8 seconds, so that as anticipated, the wind farm will produce a large amount of extra power during the event. But as you know, the power has to come from somewhere, and we don't expect a very strong gust of wind supplying that immediately. So eventually, a large proportion of that energy come from the mechanical system of the wind turbine, causing a rotor speed reduction, which we could see from the third plot here. The yellow line shows maximum rotor speed, blue for average, and red one for minimum. They all showing a decreasing trend during the event, and itself is a disturbance to the turbine, and they had to pick it up post-event. So this event shows some limits on the wind turbine generator if without additional energy storage or pre-event curtailment. And I also put down some possibilities here, maybe various H for real time, so that we don't donate too much money if we itself are struggling economically, or maybe can use some external risks, etc. So with that, that's close to the end of my presentation today. I know I only touched surface on some of the topics today. So if you would like a further discussion, feel free to get in touch with me on LinkedIn. And I also attach a reference paper here if you are interested. I think that's everything from me. Thank you so much.
Thank you so much, Jiajie. So we will cover the Q&A at the end of the session, if that's all right. Thank you. And next, I would like to welcome Juan. So Juan is a research and innovation engineer at SuperGrid Institute in France, where his main research topics are the modeling of transmission grid with high power electronic integrations and the control of HVDC transmission system aiming at transmission grid stability. Currently, he is also coordinator of the Horizon Europe-funded HVDC WISE project, which addresses the reliability and resilience of hybrid AC-DC transmission networks. He obtained his PhD in control engineering from the University of Paris-Saclay with a thesis on the utilization of HVDC transmission system for the stabilization of surrounding AC grids. Pass it to you, Juan.
Okay, thank you. Thank you for the presentation. First of all, again, can you confirm me that you can hear me and you can see my screen?
Yes, we can hear you and see your screen. Thank you.
Okay, that's perfect. And do not really hesitate to interrupt me if there is an issue with the sound or something else. Okay, so first of all, thank you everybody for attending this webinar, and of course, welcome to my presentation. The structure of my presentation, or this small presentation, is I will talk about my personal background and why I'm interested in this joint working group. What are my insights on this joint working group, and some technical developments. A very brief overview of what we are doing in our group in SuperGrid Institute. So about my background, so I might repeat something that has already been said, but I am a research engineer in SuperGrid Institute, where I have mainly two domains of interest. So how to use the HVDC systems as actuators to support the stability of the surrounding AC grid. That was the topic of my PhD that I did here in SuperGrid Institute. And the other domain of interest is the modeling, the operation, and the analysis, of course, of grids with high integration of power electronics. And currently, from October 2022, I am involved in the coordination of an EU and UK founded project, which is called HVDC WISE, and where we are aiming to address the resilience and reliability of hybrid AC/DC transmission grids via the HVDC systems, more in particular the dedicated control and protection of these grids. And this is why I think there are some synergies to find between this European project and the joint working group. The new HVDC supporting technologies like DC-DC converters, for example, and adapted configuration design of the future HVDC systems. And of course, I am a member of this joint working group. I am the technical secretary of a subgroup. As you saw before, this working group is divided in subgroups. And I am technical secretary of the provision of system services from grid forming converters. And I also participate, of course, in other subgroups for contribution and or observation. So as I said in this presentation, I am working in SuperGrid Institute, which is an independent private research and development company started in 2014, and we are approximately 170 people. We are a European leader in HVDC and MVDC expertise, and our technological solutions and services enable our clients and partners to accelerate the development of our grids of the future. We have 5 research groups in these research programs in our institute, and we have collaborated with different companies and different actors of the energy domain. Okay, so what are my insights or my expectations on this joint working group regarding the development of grid forming converters for the secure and reliable operation of the system? So first of all, I think that in this working group, we can contribute to a common understanding of grid forming controls. Of course, in the literature during the past years, we have seen that there is a lot of efforts to understand grid forming controls. I think we are reaching a common understanding, but I think in this working group we can contribute to this. Of course, also contributing to a common understanding or definition of the functions and services provided by these converters. So grid forming is not only, of course, a control strategy. We can define this as functions or services provided to the grid, and I think we can contribute to this in this working group. Something I am very interested in is this third point, in which I really would like to explore advanced functionalities of these converters, aiming the reliability of the system. So, of course, the grid forming converters, they have some inherent services or functionalities. However, we can explore how we can use them as actuators in the grid to enhance other aspects, right? Of course, contributing to the definition of an approach to test and validate those functions of grid forming converters is something I am very interested in, and more in a more personal aspect. I think in this working group there is a vast experience because we have members from all across the world, and I really would like to learn from their experience and collaborate with them and have exchanges with them. And finally, I think that participating in different projects will maybe give me the possibility to create a connection between those projects and maybe create synergies. For example, with this European project, HVDC WISE, I think there are some connections that we can make with this working group that can be very, very interesting. And then I will talk about the last part of this presentation. Will I give a very brief overview on what we are doing in our group, in what one of the research lines of our group, I would say. In our group, we are interested in high voltage applications, right? For which the modular multi-level converter has shown to be an adapted technology. And in our group, we are interested in understanding how grid forming controls can impact the modular multi-level converter. So in order to do this, we are trying to develop a whole, let's say, whole chain of models and experimental mockups covering different aspects or different levels of detail. For example, we are starting from very simplified models that can be used in RMS and dynamic phasor simulations. Of course, we increase the level of detail of those models, and we can go to the empty models. And we have also some experimental mockups of an MMC controlling grid forming control mode. So the idea is, depending on the needs of our clients or our research needs, we can go into the different models. For example, very simplified models that I call here RMS or dynamic phasor models. They can help us to understand the grid forming converter dynamics, slow dynamics. If you are interested in, for example, the frequency, in the frequency dynamics, in the low frequency oscillations, we can use these kind of models. These models are very simplified compared with a detailed model of an MMC converter, of course, and it allows us also to have a high-level control design and maybe also simulate large power systems with low computational efforts. Then we have a lot of models in electromagnetic transient simulators that allow us to understand the faster transients of these grid-forming converters. We can simulate very detailed models of these converters. And finally, we have also experimental mockups in which we can test some hardware, like controllers of power devices. So we're trying to cover all this range of models. And just to give you a very brief example of what we have done, we have published these works. We made this reduction of the full detailed model of the MMC converter controlling grid forming. We take the model of the MMC simplified from the literature, and we apply the grid forming controllers in both models. We have a comparison of these models, of course, for the dynamics of interest, which are, let's say, slower dynamics or electromechanical dynamics, I would say. And we managed to have very accurate models, again, for the dynamics of interest. Right, we can see that in the comparison, the match is almost perfect between the EMT model, the RMS model, and the dynamic phasor model. Okay, so again, this is because depending on what we want to do with these models, we can use what we have developed, either the very simplified ones, and we can go all the way around to the experimental mockups. So we have, of course, several works on these topics published in our research group. So if you're interested, you can take a look on these references. So from my side, this is it. So thank you very much for your time, and I think we can move to the questions if I'm not wrong.
Thank you so much, Juan. Thank you for your presentation. So, Charlotte, would you like to present the questions for the Q&A, if that's all right? And can I also ask Jiajie to turn on the camera if it's available, and we'll see who will be answering those questions, if that's all right.
Yes, of course. So there's been a question that came through that I believe one of our speakers has answered through the text, but there's been a follow-up to it. So I do just want to double check. So it reads, how does the event curtailment help? It doesn't increase the only source of instantaneous energy, which is the mechanical interior. I believe that that's been answered through the text, but do you want to explain that any further, and then I can read the follow-up question?
No, on the follow-up, saying whether the energy from the wind itself can provide sufficient response. To answer that one, of course, that would depend on how serious the fault would be, and also on how your grid forming setting, basically the H setting there. If you set it small, then the wind turbine is supposed to produce smaller power that might be sufficient.
Okay, great. If anybody else has any other questions, please feel free to type them within the chat box in the bottom right-hand corner of the screen. I will then be able to read those out and ask our presenters to be able to answer them. So I'll just give you a few moments if anyone does have any questions.
While we're waiting, I've got a question for Juan, if that's okay. So you mentioned about your comparison between the phasor model and also the EMT model. So when you do the comparison, have you found any challenges or problems?
Yes, of course. I mean, one of the challenges, and it's quite straightforward, is that of course on the RMS models we don't consider all the past transients, of course, and depending on what we want to study, this might be a barrier, right? What we have done to overcome this challenge, I would say, is to adapt these models, the RMS, to what we call dynamic phasor, in which we can capture some of the electromagnetic transients, but still in phasor. And with those models, we also can observe some electromagnetic transients, so we can get a little bit closer to the detailed model. However, as you know, we simplified a lot the models, so of course there are things that we are not observing. And also in the simplified models, we simplified a lot the internal dynamics, of course, of the modular multi-level converter.
Thank you so much, Juan. Thank you. And I've got another open question, I think, for both of you, if that's all right. So Jiajie obviously mentioned that they've delivered the first converter-based grid forming with a wind turbine in the UK. But what's your opinion in terms of whether the market and also the policy is ready for that in both the UK and also in France? I mean, what's your opinion on that?
Juan, would you like to go first, or like
you can go first, and I can.
Yeah, sure. Very good question. I'm not sure whether I would get a very perfect answer for that, but standing from the view of Siemens Gamesa, which is a wind turbine manufacturer, we do this testing and development so that if one day, say, National Grid requires some grid forming requirement on wind turbine, we should be ready for that. But in terms of how market would be prepared and how would that be economic, that would be a very much broader discussion. For example, in terms of extra energy storage, would that be economic to put it on each single wind turbine, or would it be cheaper, say, put it on the grid connecting point or the onshore point, whatever? So I guess there's no simple, easy answer to that one. And Juan, if you would like to add something.
Just maybe because I didn't get fully the question. Can you repeat the question, please?
Yeah, sure. I think the question is actually very similar to what Steen put in the chat. So he was asking what would be considered a realistic timeline for large-scale demonstration project, and finally commercial implementation of grid-forming converter in, for example, wind turbines. So that's actually quite similar to what I asked. So you can try to answer that. So and also especially what's the situation in France, for example.
Yes. Regarding these demonstrators or some industrial installations, I know. I mean, we're not working this kind of demonstrators in SuperGrid Institute, but I know that there are some projects that have already installed some demonstrators, grid forming converters in the grid. There was this Horizon or H2020 founded project called Osmos, in which they connected, I think, two converters, grid forming to the grid connected to batteries. So yeah, I would say that I mean demonstrators are already there, right? So there are already some attempts to have this installed in the grid. So I don't know if I could have a concise answer to the question of the timeline, but I think we're kind of close. However, there are some things that are not maybe fully answered yet, but we have to answer before, let's say, the development of a wide range of this kind of converters.
Fantastic. I can see we have another question that's in the chat. It says, what are the expected characteristics of fast transients? For example, in terms of bandwidth, have you observed these in real grids?
Maybe Jiejie, would you like to start answering or?
Is that a question to me or actually to Juan? I'm not sure.
Is it okay? Okay, I mean, in terms of the expected characteristic of fast transients, I think something important to understand is that when we are working with forming controllers, we said in presentation, we are trying to behave as voltage source, right? As an independent voltage source. So if we are working as a voltage source, we are expecting the converters to absorb these very fast first transients in the grid. For example, if we are having a load step, if we are working as a voltage source, depending on the electrical distance from the disturbance to the converter, we are expecting to absorb these first transients, right? In order to characterize this in the industry and academia, I have seen some attempts to characterize this using what they call the phase jump. So if we connect a converter to the grid, we have a phase jump in the other extremity of the line. The grid forming converter as the converter behaves as a voltage source, its angle doesn't have to move during the first instances. So this is the way the academia and industry are trying to characterize this. Have we observed this in real grids? I have seen some results again from this Osmos project where they tested some mock-ups to this kind of disturbances. However, I don't know if it has been observed in real grids.
Okay, great. If everyone's okay to hang on for a few more moments, we do have some questions left to go through. I'll try for one more, and then what I will do is I will email the presenters after this to get any unanswered questions, kind of get response, and then they will be loaded up onto the CIGRE UK website on our blog post. But I think for the last one, we'll go with the question that is, with multiple HVDC schemes on the same network and in close proximity, how shall we coordinate the GFM response of these different schemes to a frequency deviation?
Schemes on the same network. Yes, this is a very interesting question. Of course, research has to be done to understand what are the interactions of different grid forming units, right? In the grid, since just a very simple example, a grid forming converter is behaving as a voltage source, right? If we have a very close voltage source to this other voltage source, I mean, we don't have two voltage sources very close, right? This can create instability in the system. So these kind of interactions, they have to be, of course, they have to be studied. And I know that there are some efforts in the industry and academia to study this through what they call interoperability of different control schemes and different technologies and different controls of these converters. So of course it is a challenge that we have to address.
Great, thank you so much. So thank you to everybody who joined today's call. As I say, any remaining unanswered questions will be posed to our presenters post-event, and they will be added to the blog post on the CIGRE UK website. So do watch out for that in the coming few days. Thank you again to all of our speakers for joining us today and for presenting, and for all of you for taking your lunchtime out to join us. Wish you a very happy Wednesday. Goodbye, everybody.
Thank you, everyone. Have a good day.
So much. Thank you.
Thank you.
Yeah,